Hey guys, so today I am on a field trip with the 8th graders, but I did want to go ahead and make you a video so we can continue to go over the lessons I was planning for today. So we are continuing our probability unit. So an activity involving chance, such as rolling a cube, is called an experiment. When you actually do the activity yourself, it's called an experiment. Each repetition or observation of the experiment is a trial, and each result is an outcome. A set of one or more outcomes is an event. So for example, rolling a 5, which that's one outcome, can be an event, or rolling an even number, which there's more than one outcome on a number cube, can be an event. All right. The probability of an event written in this form right here, capital P, and in parentheses, whatever event you're looking for. So for example, if you're seeing what is the probability of rolling a 5 on a number cube, I would write capital P, the number 5 in parentheses. So this is what I'm looking for. So how you gauge probability is basically this scale right here. So these numbers between 0 and 1 talk about how likely an event is to occur or how unlikely an event is to occur. So if I said today is Tuesday, what's the probability that tomorrow is Saturday? You would say 0%. It's impossible, correct? However, if I said today's Tuesday, what's the probability of tomorrow being Wednesday? You would say that's certain, 100%, right? And then everything in between talks about how likely something is or is not to happen. If you have a probability of 50%, that means that event is as likely as not. In other words, is if I say, all right, I want you to flip a coin, what's the probability of getting heads on a coin? Well, that would be a 50% probability. It's as likely to happen as not, right? All right, so we're going to determine whether each event is impossible, unlikely, as likely as not, likely or certain. So as likely as not is our 50%. So this is more than 50%, greater than 50%. Unlikely is less than 50%. And of course, impossible is 0 and certain is 100%. So if we roll a number cube, so like a die, or if we have 2 dice, right? A number cube is 1 die and there's 6 sides. So what if I said rolling an odd number on a number cube? Well, on a number cube, the odd numbers are 1, 3, and 5. And so 3 sides out of 6 is 1/2. So we would say that that is as likely as not to happen. All right, what about the next one? Rolling a number less than 2 on a number cube. So how many numbers on a number cube are less than 2? Well, there's only 1. So 1 out of 6, that's a very small percent, isn't it? If I divide 1 by 6, I get 17%. So about 17%. That's quite a bit less than 50%. So we would say that that is unlikely. What about number 3? A bag holds 4 red marbles, 3 green marbles, 3 yellow marbles, and 2 blue marbles. You pull one without looking. The probability of pulling a green marble is 1/4. What is the probability of pulling a marble that is not green? Well, if pulling out a green marble is 1/4, that means pulling out a marble that's not green must be 3/4, right? Because this is 25%. Not doing this, I have a 75% chance. So that would be likely because that's greater than 50%. Number 4, Tim never listens to his MP3 player during classes. If Tim is in math class, how likely is it that he's listening to his MP3 player? Well, if he never listens to it during class, and if he's in class, that means it's impossible, right? 0%. Impossible. Lawrence finds the experimental probability of his reaching first base is 40%. Out of 350 times at bat, how many times can he expect to reach first base? So basically, we're going to turn our percent into a decimal, and we want to know what is 40% of 350. So 40% is, as a decimal, 0.4 or 0.40, same thing. So basically, we want to know what is 350 times 0.4, and I got 140 times. 140 times he would reach first base based on his experimental probability. All right, Malia finds the experimental probability of her scoring a goal 20%. Out of 225 attempts, excuse me, how many times can she expect to score a goal? All right, pause the video and figure out the answer. All right, so I want to know what is 20% of 225, and I got 45. 45 times out of 225, she will score a goal based on her experimental probability. What about this one? The experimental probability of Mara shooting a goal in field hockey is 12%. All right, I'll pause the video. I want you to do numbers 1 and 2. All right, so out of 300 shots, if she gets experimentally 12% of those, that means we're going to estimate that she gets a goal 36 times. If Scott flips 2 quarters 25 times, how many times can he expect to flip 2 heads? Well, we don't know the experimental probability, so we can only use theoretical probability, right? So every time you flip a quarter, you get, there's a 50% chance of you doing that. Well, so the first time he flips a quarter, there's a 50% chance of him getting heads. And then the second time he flips that quarter, because he's flipping 2 quarters, or when he flips the second quarter, there's also a 50% chance. So what we're going to do, when we have 2 events, we're going to multiply those probabilities together. So 1/2 times 1/2 is 1/4. Okay. So if he does this experiment 25 times, we want to know what is 25% of 25, and the answer is about 6. About 6, because we're wanting 2 things to happen, guys, not just 1, 2 things to happen. All right, what about this next one, letter A? What is the probability of rolling a 5 or 6 on a number cube? Well, a 5 or 6. So 2 sides on a number cube is a 5 or 6 out of 6, which is the same thing as 1/3. So if we conduct 180 trials, predict the number of times. So now we're talking about not experimental probability, because we don't know that data. So we can only answer this question theoretically. So theoretically, if we conduct 180 trials, I want to know what is 1/3 of 180. So I would say 60 times out of 180 times would we get either a 5 or 6 on a number cube. All right, letter A. What is the theoretical probability of rolling a 3 on a number cube? Well, how many 3s are on a number cube? Only 1, right? 1 out of 6. If you roll that number cube 24 times, how many times should it land on 3? Well, I want to know what is a 1/6 of 24, which basically means 24 divided by 6. Theoretically, you would get a 3 4 times after doing this experiment 24 times. After rolling a 6-sided number cube 24 times, Sally rolled a 3 6 times. Do the theoretical and experimental probabilities match? Well, theoretically, we would get a 3 4 times, When Sally did it, she got a 3 6 times. So do they match? No, they don't match because 6 out of 24 is greater than 4 out of 24. Right? And then the next question is, by how much do they differ? Well, in math, differ means to subtract. So we would say 6 24ths minus 4 24ths, and we would get 2 24ths. And if we simplify that, we get 1/12. They differ by 1/12. And then letter E says, what could Sally do to make these probabilities match more closely? Well, you can always conduct more experiments. Conduct more experiments. It's been proven that the more experiments that are done in probability, the closer the experimental and the theoretical probabilities will match each other. The more experiments you do. All right. So let's look at this question. The probability that an event will occur is 1/8. What is the best? Which of these best describes the likelihood of an event occurring? Well, is 1/8 a big number? Is that close to 1 or 0 or 50%? Well, when I divide 1 by 8, I realize that's only 12.5%, which is a small percentage. So I would say this event is unlikely to occur because it's a small percent. What about the next one? The probability that an event will occur is 0.9. Well, 0.9 as a percent is 90%. 90% is very close to 100%, which is certain. So I would say it's very likely. I wouldn't say it's certain because certain is 100%, right? But I would say it's likely. The next one, the probability that an event will occur is 50%. Which of these best describes the likelihood of an event occurring? Well, 50% is always going to be as likely as not. 50% chance. Marcus flipped a coin 800 times and it landed heads up 560 times. What is the relative frequency? This is another word for probability of the coin landing heads up based on the results of the experiment. So we're talking about experimental probability. So in his experiment, it landed on heads 560 out of 800 times. Okay, and they want a percentage. So I could simplify this. I don't have to. I could say 56 over 80, and then I could keep simplifying this. But since it asks for a percentage, I'm simply going to divide 56 by 80, and that is 0.7, 0.7, and 0.7 as a percentage is 70%. All right, I hope that makes sense, everybody. Let me get rid of this. A 6-sided number cube labeled 1 through 6 is rolled 600 times. An odd number is rolled 272 times. Compare the experimental probability of rolling an odd number with the relative frequency of rolling an odd number, in other words, the theoretical probability, and select one of the statements below that best describes the situation. Well, first of all, let's look at the experimental probability. So when this experiment was done, they rolled an odd number 272 times out of 600. That's the experiment. Well, theoretically, since the probability of rolling an odd number is 50%, that means theoretically, when you did this experiment, you would get an odd number 300 out of 600 times, right? So now let's look at the choices. Letter A, the experimental probability is smaller than the relative frequency. The experimental probability is less than the theoretical probability. That's not true because 300 is greater than 272. The experimental probability, oh wait, hold on, I'm sorry, I got it backwards. Okay, this was the experiment. So actually that is true. The experimental probability is less than the relative frequency. Okay, almost said it backwards. All right, so the rest of them are not true because letter A is true. All right, let's look at the next one. A bag contains 50 marbles, 10 of which are blue, 8 are red, 20 are green, and 12 are purple. Marcy takes a marble out of the bag, records the color, and returns it to the bag. How many red marbles should she expect after 500 trials? So first of all, let's figure out the probability of pulling out a red marble. So the probability is 20 out of 50, which is equal to 2/5. I'm sorry, 2/5. So how many red marbles should she expect up to 5? If we pull this out, if we do 500 trials, well, 5 times 100 is 500. So 2 times 100 is 200. Theoretically, the answer is 200. How many red marbles should she expect after 500 trials? She should expect to pull out 200 red marbles. All right, let's look at the next question. If the theoretical probability of an event is 75%, does that mean that every time someone conducts an experiment 100 times, they will get the desired result exactly 75 times? Is that what that means? No, that's not what it means. No. This is what would happen in theory. This is what would happen in theory. And I would write, but what happens in an experiment doesn't always match what happens in theory. Okay? So no, it doesn't mean that. All right, what about the next one? The bag contains 20 marbles of the same size that are blue, green, and red. The probability of picking a blue marble is 20%. The probability of picking a green marble is 50%. Determine the probability of picking a red marble from the bag and then classify the probability of picking a red marble as likely or not likely to occur. All right, so we have the color of all of the marbles. So these 3 colors make up 100% of the marbles in the bag, right? Well, the probability of pulling out a blue is 20%. So if we subtract away 20%, and then the green marble, we have a 50% probability of pulling out a green marble. That means 100 minus 20 minus 50 is 30% is left. 30% of the bag is left. That means the probability of pulling out a red marble is 30%. Because 30 plus 50 plus 20 makes up 100% of the marbles in the bag. And based on this number right here, 30%, we would say the probability of picking a red marble is not likely, or it's unlikely to occur because this number is less than 50%. All right, you guys, I hope that helps as you go through your lessons this week. So we'll definitely meet on Thursday. I hope everyone has a great week. If you have any questions or need any help, please reach out to me and I will be happy to help you. Bye, guys.